And with that, we should be live. Hello, folks.
Hey,
Flynn, nice to see you again.
likewise, Happy New Year.
Yeah, Happy New Year. All right, well, welcome to the first episode of the Service Mesh Academy for 2023. My name is Jason Morgan. I'm joined by my colleague Flynn. And Flynn, we've got something cool for folks today.
I hope so. Yeah, I
Uh,
think so.
all right, awesome. Before we get started, just a couple administrative details. One, if you've got questions either during the session or general Linkerd questions, you can best get them answered by going to the Linkerd Slack. There should be a link down below or off to that angle. That way, basically. You can join us
Bottom
on
of the
Slack.
screen.
Right. There's a Linkerd channel, which is good for general Linkerd questions, and there is a hashtag workshops channel where you can get questions answered about the content that we're going through today. And with that, Flynn, why don't you get us started? And I hear we've got a special treat. We're going to hear about a Linkerd Day.
We are going to hear about Linkerd Day. So the purpose today of today's workshop is that we're going to talk about Ingress controllers. We're going to talk about how Linkerd interacts with Ingress controllers and kind of what's up with that. By way of introduction and other administrivia, you can always reach me for questions via email as flynn@buoyant.io or on our Slack as Flynn, We are also very happy to announce that we will be doing the first ever Linkerd Day co-located at KubeCon in Amsterdam in April. Love to see you there. I will post right now the link for Linkerd Day in the workshop channel. It's a horrible link, so I'm not going to try to read it out loud. But we would absolutely encourage y'all to drop by if you are in Amsterdam. Would love to see you there. You can submit papers, which we would be delighted to have y'all show up for talks. We're happy to help you prepare talks if you're interested. Should be a really good time. And really looking forward to that. Other random quick notes there. As some of you have seen, you should be able to paste stuff on the chat for whatever platform that you're watching this on, and they'll show up here. It's a little slow, so if you're hunting for any sort of real-ish time interaction, the workshops channel on Slack is the way to go. And I think that's all. Unless you have anything else, Jason, before we get into the agenda?
No, really, that's about it.
All right. So today we will be talking about the Ingress problem, TM. We will be talking about how you solve the Ingress problem and how Linkerd works with the things you use to solve the Ingress problem. And as always, we'll get into the hands-on demo. This particular day, we're a little lighter on slides and hopefully a little heavier on the demo, which is the way I tend to like it. If you want to follow along with the workshop, you will need a Kubernetes cluster, and ideally your Kubernetes cluster should support load balancer services. You can tweak things if you're trying to do this with Minikube and you only have node ports or something, you can tweak the demo. But I'm going to be doing this with a K3D cluster that I have deliberately mirrored ports 80 and 443 back to my local host network, because that's a nice, clean way to do some of these demos. We hope you'll follow along. If you do follow along, you'll need kubectl, you'll need Linkerd, you'll need Helm. And as always, you can find the source for the workshop there on the Buoyant.io Service Mesh Academy GitHub repo. I'm going to be playing the demo a little bit riskier today. I'm actually going to show the whole thing from spinning the cluster up all the way forward. So everybody keep your fingers crossed. Worked fine last time I tried it. Hopefully the demo gods will smile upon us. All right. So let's talk about the Ingress problem. It's fairly simple. If you've got a Kubernetes cluster and you have people out in the network that you would like to have access to the services in your cluster, how does this work? And the reason that this is a problem is that kind of by definition, one of the purposes of a cluster is to isolate all the networking for that cluster and to explicitly not allow random people on the network to go and beat on your services. An Ingress controller, by design, sits right there at the boundary of the network and your cluster and provides a way for people to reach in and talk to the services that you want to let them talk to. It's important to note that Ingress controllers are a place where you can control what happens, as well as a place where you can let traffic through. It's a natural sort of choke point to do things like only allow access to some of the services in your cluster rather than all of them, or to require users to log in first, that sort of thing. There's a lot of overlap, actually, between the Ingress controller and the service mesh. They can both provide security, reliability, and observability. There's actually, I'll paste a link in a minute to a talk that Daniel Bryant of Ambassador Labs and I did at KubeCon in Detroit, where we actually demonstrate using both of them together for reliability, in particular, resilience. Another one, this question actually came up before the workshop about gRPC load balancing in particular. gRPC is a funky thing. You can't do load balancing with connections because gRPC tends to maintain connections that are very long-lived and then just funnel multiple requests over them. So you must do gRPC load balancing request by request. The Ingress controller, any Ingress controller worth its salt can do that. Linkerd can do that. Typically, either of them can do it pretty much automatically. But they work together. Oh, sorry. It's also worth pointing out that when you have an Ingress controller that does funky stuff like that, you'll often hear people call it an API gateway instead of just an Ingress controller. But both of these tend to overlap. The thing that's important to remember here is that the Ingress controller can only affect things that happen right there on the edge boundary of your cluster, where your service mesh has influence everywhere within the cluster. And for that reason, you will typically want to use both of them if you're talking about real-world production use. See a question from James on our chat here. I don't actually know where he's coming from, but just in case, Kube API, the API server for Kubernetes is kind of a lower level building block here. The Ingress controller and the service mesh will both interact with the API server to interact with Kubernetes resources. So none of this will replace the API server. Hopefully that answers the question, but if not, let us know. Okay. Now that I've lost track of my mouse, there we go. All right. Another note is there is a resource whose name is Ingress in Kubernetes. And it's very important to realize that when I'm talking about an Ingress controller here, I'm talking about Ingress, the concept, that concept of allowing access to certain services within your cluster. That does not necessarily imply using the Ingress resource. And in particular, the Ingress resource is honestly pretty old and fairly limited. If you've heard stuff about the Gateway API, one of the big purposes of the Gateway API is sort of to be the next level Ingress so that we can get away from the limitations of the Ingress resource. So it's very important to separate those two things. Okay. Thank you, host, for the reminder about the workshops channel on Linkerd Slack. I think I'm going to leave that banner up with the Slack info just in case people are still curious there, or at least for now. Okay, so backing up to this picture here where we've got people on the outside of the cluster speaking through an Ingress controller to services on the inside of the cluster. This raises the question of, all right, so how does Linkerd work with these things? And the answer is actually that from Linkerd's point of view, the Ingress is just another meshed workload. So for the most part, Linkerd gets to be thoroughly agnostic to which Ingress controller you're using. You arrange for the Ingress controller to participate in the mesh. MTLS works, all the service and resilience, all the security and resilience stuff that Linkerd provides just work. We're actually going to show some of that in the demo today. And this is one of the things that's actually really nice about Linkerd. Some of the other service meshes have a tightly coupled Ingress, or they do special things with the Ingress controller. One of Linkerde's big purposes is to just try to be really simple. And this is one of the ways in which we get to be really simple. You can use whichever Ingress controller you want, and they pretty much just work. I am, of course, saying pretty much just work. There are a couple of gotchas, so let's talk about them really quickly. Don't worry, they're fairly minor gotchas. The first one is, sometimes the Ingress controller needs to know the IP address of an incoming connection. Sometimes you want to do things like, oh yeah, if I get a request for the foo service from my internal chunk of CIDR, then I want to allow that. But if it's some bozo out on the network, don't allow that. If you need for your Ingress controller to know the IP address from which a connection originates, you must tell Linkerd to skip that incoming port. If you do not tell Linkerd to skip that, the Ingress controller will only ever see the IP address of the Linkerd sidecar proxy, which is not going to be very useful for any sort of policy decisions like that. Worth noting, if you're using an Ingress controller that's worth anything, the entire purpose of the Ingress controller is to sit there on the edge, exposed to the internet, and so it should always be safe to skip those incoming ports. Linkerd is really not going to be offering you anything if you don't skip them anyway. Also worth noting that if you are not using the IP address for anything, if you forget to skip the ports, nothing major is going to happen, but it's not a bad idea. So to actually do this, you're going to use an annotation that goes on the Ingress controller's pods, config.linkerd.io/skip incoming ports. Very important, you must use the target ports, not the services ports. So if we've got our fancy Ingress service here, you can see that that service is set up to listen on port 80, but it will map traffic back to port 8080 on the fancy Ingress pod. That means that the Linkerd proxy running with the fancy Ingress pod will only ever see connections to port 8080, not to port 80. So you need to say skip port 8080, not port 80, as I've shown up above there. Okay. Second gotcha. Linkerd has a thing called Ingress mode. To kind of skip ahead, you really don't want to use this, but let's talk a little bit about why it exists and why you might actually need to use it. Linkerd tends to expect that you're going to make connections to the cluster IP for a workload, by which I mean you've got a service. That service brings traffic to a workload. The workload has multiple replicas, which we call endpoints. Linkerd expects to see connections made to the single IP address for the service, and that will allow Linkerd to go through and then choose one of the endpoints for you using its load balancer. Purists who know a lot about Linkerd, I would like to point out that I am well aware of the fact that this diagram is more conceptually accurate than technically accurate. Let's just move on and not worry too much about that. The point here is that the well-behaved Ingress controller will connect to a service by looking up the service's DNS name or knowing its IP address, something like that, and it will then allow Linkerd to do the load balancing at the service mesh layer. Generally, Linkerd does have the characteristic, though, that if the Ingress connects directly to one of those endpoint IPs, Linkerd assumes that the Ingress or whatever client is doing something like that knows what it's doing and is trying to do some sort of advanced load balancing. So it will just skip the Linkerd load balancer and go straight to the endpoint that the client workload is choosing. Sometimes this is what you want from the Ingress. For example, Emissary Ingress actually has the Kubernetes service resolver and the Kubernetes endpoint resolver that allows it to select which of these behaviors it's going to do. Nginx has an annotation that can pick which of these it will do. So if you want to do something like sticky sessions where the Ingress controller is controlling, if the Ingress controller is doing sticky sessions for you, you will need the Ingress controller to do this for you. On the other hand, some Ingress controllers, like for example the Envoy Gateway, can only go to the endpoints. They just don't know how to do anything else. For situations like that, we have Ingress mode, where if you annotate the Ingress pod with inject::Ingress instead of inject::enabled, then it enables a behavior where Linkerd will inject an extra header into the request as it's moving from proxy to proxy, so that Linkerd can sort of undo this behavior of going straight to the endpoint. Again, you don't want to use this if you don't have to. It makes things a little tougher to reason about, and it's just better to use an Ingress that does not need this mode, but it's there if you really have to have it. And on that note, that's actually it for the slides, because in a lot of ways, Ingress with Linkerd is fairly straightforward. So let's take a couple of seconds just to make sure there are no other questions from Jason or anybody else before we go on. Carry on.
I was going to say thanks a ton for that, Flynn. So folks, again, if you're watching, if you get a chance, please do join the Linkerd Slack, slack.linkerd.io, and get it down there. Head over to the workshops channel and ask questions. Yeah, would love to. The more we interact during this, the better I think it is for everybody. Thanks.
It's also much more entertaining generally. Okay, demo time. We're going to demo 3 different Ingress controllers with Linkerd. We're going to do, actually, I should have reordered these to match the order we'll actually do them. In order we're actually going to do them, we're going to do Emissary Ingress, that's the one in the middle. We're going to do Nginx, that's the one on the left. And we're going to do Envoy Gateway, which is the one labeled Envoy Gateway. So let's hope the demo gods are with us, shall we? Yeah. All right. So, as always, I should have put this up at the very beginning, but we've posted the link to the source repo for all of this. You can go follow along there, and you'll be able to see exactly what I'm running by looking at that. Let me turn this off. And it still covers up the bottom. Thanks, Restream. Let's, all right, well, something to remember for next time. Excuse me. As I mentioned earlier, I'm doing this the slightly dangerous way, where I'm starting out by creating my cluster and showing everything from creating the cluster to installing Linkerd and all that stuff. The important bit for reading over creating the K3D cluster here is basically all of this deals with random stuff specific to K3D, but the most notable ones are, in addition to the fact that I'm telling it not to deploy traffic and things like that, I'm explicitly telling it that I want it to expose some of the ports from the cluster back to my local network, just because that will make it a lot easier to run this demo and let y'all actually see traffic flowing through. So off we go. Hopefully none of this will take too long. It's always so much fun watching things like this and going, oh, I hope this works.
If you're watching on YouTube or Twitch, we've sent over the link to the Git repo, and that's also going to be available in Slack. If you're looking just for more information on Linkerd and Ingress, and you want to read through the docs, we're going to send a link over to the Ingress section of our docs in a minute.
Yep. Okay. So we have now a running K3D cluster on my laptop. Next thing, we need to install Linkerd itself. We are doing this bit straight out of the Linkerd Quick Start. If you Google Linkerd Quick Start and look for that, you'll go find it. We could also post a link to that, Jason, if you take care of that, please. So we first install the Linkerd CRDs, then we install Linkerd itself. And you'll notice this pattern where I'm running a Linkerd command and then piping it to kube control apply. That's a typical Linkerd thing to do. Now I'm going to install Linkerd Viz, which is the visualization extension to Linkerd. We're going to use that to kind of take a look at what's going on. Take a look at what's going on within our application, I should say. There, hopefully that'll be a little easier to read now. Okay, there we go. So Linkerd viz there was waiting for Linkerd's control plane to become available before installing viz. Now we're going to run Linkerd check again so that we can wait for Linkerd viz to become available rather than going and running everything before it becomes available. All right. Okay, so now Linkerd and Linkerd viz should both be running. I actually trust that pretty well. The last thing we're going to install here before we get into any Ingress controllers is we will install the world famous Emojivoto demo. And this is also straight out of its quick start, with the possible exception that I don't remember whether the quick start injects it at the very beginning or not. But what we're doing here is we're grabbing the Emojivoto YAML using curl. Then we pipe it through Linkerd inject. Linkerd inject will modify the deployments to insert the Linkerd proxy next to everything. And then we're piping that into kubectl apply. Off we go. This section with all of this skipped stuff is Linkerd inject talking about what it's skipping and what it's injecting. This is kubectl apply's output. And now we're going to wait for Emojivoto to be running. It's all running. Excellent. Okay, so at this point, we have a running cluster. It's running Linkerd, it's running Linkerd viz, and it's running Emojivoto. So let's see about getting some Ingress controllers going. First things first, Emissary Ingress. Emissary is an open source Envoy-based Kubernetes native API gateway. Full disclosure, I am Emissary's original author, so it's the one I'm most familiar with. You can find it over at getambassador.io. Its source code is on GitHub under the Emissary Ingress organization. And we are mostly following Emissary's quick start here. I say mostly because Emissary, if you follow the Emissary quick start, you'll get the high availability install for Emissary, which has 3 replicas. We don't need 3 replicas for this particular demo, and having all 3 of them makes it harder on K3D. So I'm going to use the magic of sed to chop that down to only 1 replica. And I'm also going to use Linkerd inject to go ahead and bring Emissary into the Linkerd mesh right from the start. So I'm going to create the Emissary namespace. I'm going to pull down the Emissary CRD YAML. I'm going to chop the replica count to 1. This is actually relevant for the CRD YAML because Emissary includes a deployment in there that handles CRD upgrades and such. And then I'll do kubectl apply. Off we go with that. We'll wait for that to be ready. Those of you who have seen other Service Mesh academies, you'll recognize that I tend to use Emissary for most of those, but I rarely go through talking about how we actually install it. So here we go. This is the one where we talk about all this stuff. We're going to repeat pretty much exactly the same thing to get the actual Emissary deployments, with the distinction that in the middle of our pipeline here, we're going to do a Linkerd inject as well. So there's that. Now, even before we wait for everything, I'm going to demonstrate that skip incoming ports annotation. So I'll go ahead and annotate all the I'm going to annotate the Emissary Ingress deployment, and then I'll wait for everything to be ready because the annotation will restart things. I'm not actually going to do anything with that in this demo, but I wanted to actually show how that's done, and I wanted to show where it kind of makes sense to do it if you need to do that sort of thing. All right, so an Emissary Ingress is now up and running. And at this point, we need to actually configure Emissary to allow some traffic through to Emojivoto. Emissary brings in its own configuration language CRDs. At minimum, we need a listener to tell Emissary what port to listen on. We need a host to tell it what sorts of hosts it should care about. And we need some mappings to tell it which traffic to actually route where. So we'll take a quick look at those, not a really detailed look. This particular one, we're going to tell it to listen on 8443 for HTTPS. We're going to tell it that it should pay attention to the wire protocol for matters of security. And we're going to tell it that it will allow any host and any namespace to associate with this listener. Same thing, port 8080, but we're just going to do HTTP there. And finally, we will allow traffic to any host name, and we will also allow traffic to any host name to actually route insecure requests, meaning HTTP. The reason for that is I didn't really feel like cluttering up this demo by enabling TLS everywhere. So let's go ahead and let's go ahead and look at the mapping. After the listener and the hosts, we also have a single mapping. Our single mapping says, if you see any traffic where it begins with a slash, which is to say anything, and it has a host name of emoji.127-0-0-1.sslip.io, it will go to the web service. Sorry, it will go to a service named web service in the Emojivoto namespace. If you're not familiar with SSLIP or sslip.io, it's actually really cool. The names of this pattern, so anything dot an IP address dot sslip.io resolves to that IP address. So in this particular case, I can just randomly create a name that will always resolve to localhost, which makes it really easy for me to go through and set things up on my localhost and then still do name-based routing. I just learned about that recently. It's really cool.
That's absolutely fantastic.
It's
made my life a lot easier in that one.
I want to actually let me do a shout out. I heard about that from, oh crap, I can't remember if it was the Cert Manager guys or the Fairwinds guys, but one of those two, both cool, cool companies, cool projects. One of them was the one that told me about this recently. So yeah, go check them both out, since I'm doing the horrible thing of not remembering which one it was. But yeah, really cool. All right, so we're going to imply all those things. And that's it. Emissary should now be happy to route some requests for us. So let's see. Over here, I have a browser pointing at that host name. And if I reload it, it works great. I can go through, I can look at my leaderboard, I can vote for some emoji. I can't vote for donuts because Emojivoto is always broken for donuts, but I can vote for other things, which there we go. So we have a working Ingress. If I come back and I look at the Linkerd Viz dashboard, I can see that Emissary is in fact meshed, and I can go click into the Emojivoto namespace and I can look at my web service there, and I can see, hey, look, Emissary Ingress was talking to us with a success rate of 100%. So just from this, we get to see that Emissary is part of the mesh. We get to see that it is correctly talking to the service we want it to be talking to when we make requests. We get to see that things are working. And we can also know, I've shown before how we could dig through and observe that MTLS is happening. I'm not actually going to do that right now, just in interests of time. But yeah, there you go. It's working. We ran a few commands. We got the thing in the mesh. And now we have all of these things happening all the way through. Yay. All right. So next up is actually, let's clean up after doing Emissary. Excuse me. I could actually go and do a bunch of kind of weird headachy things to go and delete all of this, but I'm going to do it the cheap and sleazy way and just scale the replicas down to 0 and remove the service. The really important bits here are actually, the only really important bit here is removing that service, because that service was listening on port 80, and I'm about to use port 80 to run another Ingress controller, right? So I have to get rid of the service or very bad things will happen. Also, since I'm running K3D, I'll scale the replicas down just so I'm not burning CPU and having all sorts of crazy things happen there. Okay, on to Nginx. And once again, if you got questions, the workshop Slack is a great way to do that. But so far, things are looking good. All right,
Yeah, we've
Nginx.
had
Go ahead.
some great questions, but they seem to be getting answered in line.
Which is awesome. It's especially awesome because some of them are questions I'm not entirely sure I could have answered. So it's lovely to see my brilliant colleagues going through it, taking care of things. Big shout out to Alejandro, by the way, who's watching all of this stuff and helping us out here. All right, let's talk a little bit about Nginx. Nginx is a little interesting. It actually predates Kubernetes, and it is a web server as well as an Ingress controller API gateway thing. I'm not actually going to show off that part of Nginx. I'm going to use it as an Ingress controller. The fact that it predates Kubernetes, on the one hand, means that it's mature and battle tested, and on the other hand, means that occasionally you can run across things that don't feel very Kubernetes-ish about it. So, something to bear in mind. But obviously, it's very popular, and it also works great with Linkerd. Nginx.com will take you to a bunch of information about Nginx. If you are reading Nginx.com, be aware F5 owns Nginx at this point, and F5 will want you to go and look at Nginx Plus, which is their commercial offering, in much the same way that Ambassador Labs will try to get you to look at Ambassador EdgeStack rather than Emissary, because that's their commercial offering. But both of these products do have fully open source versions that work great. Nginx is also interesting because it uses Mercurial rather than GitHub, so that was a little interesting to find about that. We're going to use Helm to install Nginx. Part of that is because the instructions for installing Nginx with Helm were really simple. And part of it is because why not show off the fact that you can use Helm and mix and match all sorts of stuff, right? So let's go ahead and get the Helm install going. Yeah, I already added the Helm repo. That's fine. So there's the Helm install. We're doing this just completely default. We're not modifying any of the values or anything like that. We do have to manually install Nginx afterwards. Manually inject Nginx into the mesh. And we do that by using kubectl to read the deployment out of the Kubernetes cluster. Then we feed that into Linkerd inject to get the proxies. That will produce modified YAML, which we will then reapply with kubectl apply. So off we go. Excuse me. Nginx is one of the things that actually uses the Ingress controller, the Ingress resource that we were talking about. Wow. So here's an example of an Ingress resource. A couple of interesting things. The Ingress resource has to go in the namespace that the service to which it is routing lives. The Ingress resource doesn't really want you to do cross namespace stuff. Another important thing is, by default, Nginx will do the thing where it tries to go straight to the endpoint for you. We're going to use this service upstream annotation, which is specific to Nginx and goes on the Ingress resource, to tell it not to do that. We are going to explicitly tell Nginx, no, don't go straight to an endpoint. Look up the service and go to the service's cluster IP. That will allow Linkerd to do all of its Linkerd magic later on. This Ingress class name, Nginx, the Helm install created an Ingress class resource with a name of Nginx. The rules for Ingresses are that most of the Ingress controllers that use the Ingress resource also use the Ingress class resource. That's a way of arranging it such that you can have multiple Ingress controllers that all use the Ingress resource, but only, each individual controller only looks at its Ingress resources. You're going to see a similar pattern to this when we look at the Envoy Gateway and the Gateway API. In this particular case, the critical thing to know is that the Helm install created an Ingress class whose name is Nginx, and Nginx will ignore any Ingress resource that is not explicitly marked with the Ingress class name Nginx. Beyond that, for the host whose name is emoji.127.0.0.1 we're going to do HTTP. We're looking at specific HTTP paths. In this particular case, we're looking at a prefix of / that will go to the backend named web service on port 80. So functionally the same as the emissary mapping we saw earlier. Take all the HTTP traffic and route it to the web service. It's a different resource, so it looks really different. So we will apply that, and done. Now we should have Ingress routing traffic Nginx routing traffic for us. That's what I get for looking at the thing, reading Nginx Ingress.yaml while I try to say that. So let's take a look at that at the browser. If I come over here and reload, hey, it works. Excellent. Once again, I can go through and I can vote for some emoji. And yeah, all well and good. So I can also, once again, fire up the Linkerd viz dashboard. And I can see, actually, Nginx weirdly installs itself by default in the default namespace. So we see that the Nginx Ingress deployment is fully meshed. Always nice. If I come back and then look into the emoji voter namespace, once again, I'm now seeing deploy Nginx Ingress is talking to Emojivoto's web service. I no longer see Emissary because Emissary is gone. But again, most of the work here was just in installing the Ingress and in telling it to go ahead and be part of the mesh. We did have to take the extra step with Nginx of explicitly telling it to do service-based routing rather than endpoint-based routing. No big deal. So cleaning up for the next one, we're going to just do a Helm delete of Nginx. That will not actually delete the Ingress resource. That's still lingering around, but it doesn't matter because nothing's paying attention to it anymore, so who cares? In much the same way, the emissary configuration, like the emissary listener and hosts and mapping, those are still lingering around too, but again, nothing's paying attention to them, so we don't care. All right, last one. We're going to talk a little bit about Envoy Gateway here. Envoy Gateway is very new. Sorry, Jason, were you going to say something?
Well, I was going to say, Flynn, I'm curious. I've heard a little bit of talk about this. Could you give me some context about what Envoy Gateway is?
Indeed, I can. Envoy Gateway is a very new project. It was announced at KubeCon Valencia less than a year ago. And it basically goes like this. If you look in the CNCF, you will find not one, but two, or, last year, you would have found not one, but two Envoy-based CNCF Ingress controllers. You would have found Emissary and you would have found Contour. And the more the Emissary folks and the Contour folks and the Envoy folks talked, the more everybody realized that they were duplicating a tremendous amount of effort. And so the Envoy Gateway project is basically those three groups getting together and going, suppose we just make a standalone Envoy proxy thing based on the Gateway API and stop duplicating quite so much effort across the industry. Instead, we can use Envoy Gateway as a thing that you can build on top of instead of using Envoy and then having to build all this extra stuff on there. So for example, Contour and Emissary both had to spend a lot of effort in going through and watch all the Kubernetes resources, maintain the care and feeding of the Envoy XDS servers, do all the translation into the Envoy XDS API, which is a royal pain. Things should be simpler for both of those projects to basically interact with the Gateway API rather than trying to interact directly with the Envoy stuff. You can read more about Envoy Gateway at gateway.envoyproxy.io. Its source is on GitHub under the Envoy Proxy organization. Full disclosure, I am also involved with this project, although mostly in an advisory or heckling sort of capacity. Not sure which of those is more accurate, honestly. But Envoy Gateway seemed like a pretty obvious thing for this talk. It's sort of up and coming. It is dealing with the Gateway API, which is a direction that Linkerd is going as well. Also, full disclosure, I'm involved with the Gamma project, which is worrying about how the Gateway API interacts with service meshes. So There are a couple of interesting things about Envoy Gateway, which we will see when we install it. But so we'll start off by installing it pretty much from its quick start. If you were reading carefully, you will also have seen the v0.2.0. Envoy Gateway is very new. And so lots and lots of things are changing fairly quickly. I was kind of hoping to use Envoy Gateway 0.3.0, but that's not going to be out for another couple of weeks. All right, so there we go with that. Maybe longer than another couple of weeks, actually. So we have that running. Now, I mentioned earlier that when we were working with Nginx, we had the Ingress class and then we had the Ingress resource. In the Gateway API, we have gateway classes and gateway resources. Basically, the old Ingress resource kind of got split into the gateway resource and the HTTP route resource to separate the concerns of managing the gateway and understanding ports and TLS and all that crap from the concern of routing to your application. One of the interesting things about the Gateway API, though, is that the Gateway API has kind of baked into its DNA this idea that creating a gateway resource causes the controller for the Gateway API to spin up whatever deployments you need to manage that gateway. That means that the infrastructure in the gateway, when you're working with the Gateway API, the infrastructure of the Ingress side of things tends to be very dynamic. In turn, that means that the previous technique where we went through and we would read out a deployment and then inject it into the mesh, that doesn't work with Envoy Gateway, because every time you edit the gateway resource, the deployment for that gateway resource changes. So instead, what we need to do to make this work smoothly with Linkerd is we mark the entire Envoy Gateway system namespace as auto-inject, so that anytime a new pod shows up anywhere in that namespace, no matter what it is, it will be immediately injected by Linkerd. You can do this for Emissary or Nginx or any other workload you care to, really. But it is interesting that it is necessary to make Envoy Gateway work smoothly. So we'll go ahead and do that. Since we just annotated the namespace and we didn't annotate a deployment, none of those pods got restarted. So let's go ahead and do a rollout restart and wait for Envoy Gateway to be running again. Anytime, Envoy Gateway. There we go. And now we can go through and take a look at the Gateway API resources that we need to use to configure Envoy Gateway to route to Emojibo. There are 3 of them. The Nginx Helm chart created an Ingress class for us, but nothing in Envoy Gateway creates that automatically. So we are going to create by hand a gateway class whose name is EG, which is the very funny abbreviation, or at least I find it funny that the Envoy Gateway people like to use EG a lot. This magic controller name is the one that Envoy Gateway looks for in the gateway class so that it can understand which gateway classes it should pay attention to. Because this name is not important in the gateway class. What's important is the controller name behind it. Once we have a gateway class, we can create a gateway. It is also named EG, much like the Nginx Ingress had an Ingress class name. We have a gateway class name in our gateway. And this is saying, okay, so we're going to listen for HTTP on port 80, and we're going to allow routes from every namespace. If you forget the allowed routes from every namespace thing, none of this will work, and it will be very confusing. Because much like the Ingress resource, the routes really want to be in the namespace for their workloads. That means that it doesn't really make sense to put the gateway in the Emojibodo namespace, but that means that we need to put the route in the Emojibodo namespace and then still be able to link it back to the gateway in the default namespace. So parent refs talks about which gateway this route is associated with. Host names, that should look familiar by now. When we look under our routing rules, we have a matches section that's talking about the paths we're going to match in this case. Again, we're basically going to match everything. And we have some backend refs which in our case, we're going to say we're going to go to the service whose name is web service on port 80, and the weight of 1 means take all the traffic there. All right. And I'm not going to talk about the group because I should have removed that. So let's go ahead and get that applied. And there we go. Since we just did the gateway, we're going to go ahead and wait for the Envoy proxy deployment to be spun up. It's spun up. Great. Envoy proxy should be routing for us. In practice, I've found that it's the slowest one to get ready, so we might actually have to try a few times. Once, twice, third time's the charm. Okay. Whew. It always worries me. Every time I've done this, it always worries me. But here again, we can go through, we can vote for some emoji, we can view the leaderboard, all is well. And once again, let's switch back and take a look at the biz dashboard. There we go. We can look at Envoy Gateway system and see that it's all meshed. We can look into Emojiboto, we can look at the web, we can see this delightfully named Envoy default EG 6465661. No, I don't know where that number comes from, but we can see that it's meshed and it's talking to us and good things are happening. So that's actually about it. We got to watch 3 separate Ingress controllers, all of which were working cleanly with Linkerd. None of which required a whole lot of effort on the part to get them working with Linkerd. We pretty much just ran them through and started them up and off they went. Obviously, all of them did have a couple of little quirks for things that you had to pay a little bit of attention to. Worth pointing out, when I was doing this, I did not bother to do the skip incoming ports part for Nginx or for Envoy Gateway. And again, if you are using this in the real world and you need to see the IP address of incoming connections, that's a thing to worry about. But other than that, there you go. So I think we have plenty of time for questions today, which is nice. So Slack is a great way to hand over questions if you have any. There, once again, is the link for the GitHub repo that I was working from. And as always, feedback is great.
Well, thanks a ton for that, Flynn.
Not a problem. Thanks for emceeing.
Yeah, that was the Gateway API one. The Gateway API one I find interesting. Or sorry, the Envoy Gateway one I find interesting. All right. So just to be clear, the reason you annotated the namespace was because you're using an operator and a new custom object to actually create that Ingress, or sorry, that Envoy Gateway instance that we're talking to. And so we annotate the namespace, and it allows it to pick up.
Right.
Okay, great.
When I was doing this the first time, I created the gateway object and everything was great. And then I went ahead and injected everything by hand and all was wonderful. And then I realized I'd done something wrong in my gateway object. So I tweaked it and all of a sudden nothing was working. So it's not a subtle thing if you get that wrong, but it is interesting because that business of that dynamic infrastructure concept that's kind of baked into the Gateway API. If you are a cluster operator or if you're in the platform engineering team, there are ways that can be really natural. And if you're an application developer and you're used to dealing with the way other ingresses deal with that, then it can be confusing when you first run across it. So it's a good thing to be aware of in terms of a thing that's a bit different.
Got it. Well, looks like we're clear on questions.
All right. Well, let me flip back to the slides for a moment, since there's a couple of things we should mention as well here, I think. As always, we do the Service Mesh thing every month, Service Mesh Academy thing every month. This month in particular, we also have another thing going on where next week we're going to be doing a webinar with Weaveworks. And then for February, we'll be doing a workshop with Weaveworks. If you go to the Service Mesh Academy link at buoyant.io/SMA, and you look at the sign up for the February 16th thing, you'll also find a link back to the webinar on the 24th. That promises to actually be really interesting. So hope to see y'all there. These are both free, by the way, just to be clear about that. And as always, we would strongly encourage y'all to go and check out Buoyant Cloud as well. I didn't talk about it in this particular workshop because I was afraid we were going to run out of time. That was clearly a mistake on my part, but it's pretty cool. Yeah, those of you who've been to other Service Mesh Academies, you will have heard us wax rhapsodic about it and seen demos before. It's kind of nice. And I believe that is about it. There's how to reach me just in case. And yeah, if anybody has questions, now is a lovely time for them.
And of course, if you miss this or you're talking later, you can always go to that workshops channel in Slack and talk to folks. People will absolutely find their way around answering it. I know I spend time looking around for new posts in there.
Yeah, definitely. And I see some people typing in Slack, but I don't know if they have questions. Nginx Plus does offer a mesh as well. Yeah, there's I know that F5 is talking about an Nginx service mesh. I don't know how far along it is or anything like that. I don't even know if it's a commercial thing, although I assume it is. I don't know. So we'll see. Adriano asks, do we see Linkerd competing with the Nginx service mesh? I mean, it's another mesh. So to the extent that we compete with other meshes rather than just obviously being the one to choose, yeah, we'll probably compete with that one. I mean, I'm being kind of facetious. I truly don't know anything about Nginx mesh, but I mean, I don't know. It sounds like a service mesh. Sure, why not? Oh, Michael O'Leary works for F5. Great, awesome. Well, so there you go. There's somebody who can talk more about it, because yeah, I don't really know anything about it at all yet. Dominic, yeah, it's very weird when nothing goes wrong. Don't get me wrong, I'm not complaining. I think it's great. It's just, I always feel like I've forgotten something, you know?
All right. And with that, really appreciate everybody's time, and we'll see you at the next one.
Sounds good. Thanks much, everybody. Appreciate it. See y'all on Slack.